Good morning, good afternoon. This is Rakesh Kumar, and I'm working in Silicon Technology. I work as a cloud specialist. My day in, day out job is to take care of cloud operations, engagements, and propose the solution around the cloud technology. Uh, Moving next. Uh, in this recording, I'm going to have a couple of agenda where we will be discussing cloud computing fundamentals, Windows Azure service models, Windows Azure storage, high availability, and Windows Azure services. So I haven't prepared a presentation. Just I have took good presentation around the net, and I would like to go through with that where I can share my understanding with you guys. So let's move on. Next is cloud computing fundamentals. What is cloud computing? So as everyone knows, right? Cloud computing is buzzword nowadays, and it's getting discussed in each and every industries, either a technology or non-technologies, where business people are consuming services. So they also used to discuss about the cloud. This app is coming from cloud. Our application has been running in cloud, or we are offering cloud services like that. So, first of all, we need to understand what is the cloud. Cloud, it's nothing but technology. The way we were offering earlier, it has been changed, and it's new paradigm of IT services being offered to enterprises. Uh, and yeah, as per the reports, right, cloud growth in the market, you can see it moving forward. There are a lot of demand in the cloud areas. Still, industries are evaluating their services to be compatible or their business to be compatible into the cloud. Not only technology aspects, in regulatory aspects as well. Regulatory compliances are there, allowing them to move into cloud or not. So it is mentioned as one of the top five technology trends to watch in next 4 5 years, uh, as Gartner says. And by 2020, cloud will be dollar 241 billion market, which is a really big market, and where industries will be uh, working on. And we need technical people to be support that cloud. Most enterprises are slowly moving into the cloud, means adopting cloud slowly. Cloud is the way to run IT in the enterprise for now and future. So this is the way to run the IT into the in future. It's not just a software which will be running. Overall, IT business will be running in the cloud. So, in moving forwards, we will be discussing more about how enterprises will be compelled to move into the cloud. There are a lot of benefits. There are a lot of challenges and a lot of business value moving into the cloud. So, we will dive a bit into the cloud computing history, which is pretty interesting. People thinks that cloud has been came just recently, but it's not. It's a evolution of our philosophy around the technology. So cloud computing history, you can see the idea of cloud computing. It's being discussed very early in 1961, but terms were different. but the concept were getting discussed quite early. So, computer scientist, right, John McCarthy publicly proposed in 1961. What was that? He mentioned computation may someday be organized as a public utility. The computing utility cloud become the basis for the new and important industries. So that's where people were discussing about. So as we will discuss, before cloud, there were term utility computing to support huge computation power. So, cloud computing history, as in 1969, Leonard Kelmarock, a chief scientist of the Advanced Research Projects Agency Network, or Apparent project that seeded the interest, stated as of now, computer networks are still in their infancy, but as they grow up and become sophisticated, we will probably see the spread of computer utilities. So that's where these people were keep on saying by seeing that time challenges, and they forecasted about the future. So early adopters of utility computing were a couple of big companies, right? So in 1990s, as we know, Yahoo, Google, these search engines were offering as a cloud, as a utility computing. Means they were giving a one portal from there. They will be serving use software offerings like webs, search engine, news, uh, uh, email services. That was the starting point of utility cloud, and that those this Yahoo and Google, Hotmail were early adopter of the cloud computing. So these services were not a standalone software, right? These softwares were getting offered in web. So how people were coming to their portal and consuming their services, and millions of users were using those softwares concurrently. So how, it was not possible from the one data centers because these services were getting offered across the world seamlessly, and if that time they would be thinking about hosting one service into one data centers, eh, it was not possible to run this massive level applications. So that time, this thought arose in the market, and these early adopters adopted utility computing and uh, uh, started giving their software as a utility. In late 1990s, Salesforce.com pioneered in notion of bringing remotely provisioned services into the enterprise. So we know, right? Salesforce started offering uh, its product and services from the web. So enterprises started using cloud offering from Salesforce.com, and uh, that rollout at massive level, enterprises were using across the globe concurrently, million users. Uh, so it wasn't possible without having scalable, reliable uh, data centers across the world. So that's even these bigger players build their capability into the cloud, and they offered Salesforce. In 2002, Amazon.com launched the Amazon Web Services (AWS) came into the picture, and uh, a suite of enterprise-oriented services provided remotely provision storage, computing resources, and business functionality. So Amazon's realized and the business challenge, and they started offering uh, um, uh, IT services like storage as a service, computing as a service. So Amazon realized early and started working on and started delivering services around storage, computing, and network. So that's where Amazon becomes one of the biggest player in the market. So in 2006, the term cloud computing emerged in the common commercial arena. Uh, Before that, we were using utility cloud, right? Utility computing, and in 2006, this term cloud computing got popular or it started emerging in commercial platforms. People started discussing about cloud computing and offerings. Amazon launched EC2 at that time, which is nothing but compute as a service. Means a machine you can get as a in form of service. So, means service, we know, right? Whenever we want, we can take, consume it, and whenever want, we can stop it, and we will pay whatever we have used. So that's what we say the service. So Amazon started offering EC2 as a lease. Lease means computing as a service, and Google all at that time started giving Google Apps, also began providing browser-based enterprise applications where we were able to get Google Drive, Google Docs, Google Plus, G Plus, email services, uh, Hangout. All these applications were getting offered in the browser itself, uh, and it was not possible without having massive computing capability behind these applications. So that was the bit history. We will be now discussing about cloud computing definitions. What does cloud computing mean? So we will see a couple of industry standard definition about the cloud computing. As Gartner, right? Gartner says a style of computing in which scalable and elastic IT enabled capabilities are delivered as a service to external customer using internet technology. Means you are delivering IT capabilities in a elastic manner over the internet. That means you, that is the cloud computing. Forrester is standardized IT capabilities. IT capabilities, it's clearly means in services, software, or infrastructure delivered via internet technology is a in a pay-per-use self-service way. Mean whatever you're using, you're going to pay, and self-service whenever you want. You can consume whenever you want. You can stop, and whatever you want, you can use it. Means there is no restriction. You want to use very small computing power machines, you can get it over there. You want very small or very big storage system, you can use it. So that's how these definitions came in, and one of the best definitions from the NIST, which covers lot of areas during definitions. So here they define cloud computing is a model for enabling ubiquitous, convenient, on-demand network access, and second, to a shared pool of configurable computing resources is a network, servers, storage, applications, and services that can be rapidly provisioned and released with the minimal management efforts or service provider interactions. This cloud model is composed of five essential characteristics, three service model and four deployment model. Guys, keep in mind last point. This is the uh, very key characteristics of cloud computing. Means cloud computing is a composed of five essential characteristics. We will discuss in more detail, and three service model. So it has a three service model and four deployment models. So cloud computing, five essential characteristics. What are those characteristics? Means based on these characteristics, we can say that okay, this is cloud computing system. So these are on-demand self-service, broad network access, resource pooling, rapid elasticity, measured services. So these are the five characteristics of any cloud computing. Any cloud providers, if they are having these five characteristics, we will say those are cloud computing. Means anyone can become a cloud provider if their data centers has these five characteristics. We will delve into more detail about these characteristics. Uh, so, on-demand self-service, broad network access, right? So, on-demand self-service means capabilities should be provided in a such a way that consumer can request or provision by own as it buys like a shopping cart, shopping portal, and your computing should have a broad network access. That means it should not be limited to a particular location. Your services should be offered in a broad, geographically distributed. Resource pooling. Your resources should be pooled. Uh, means like a carpool, right? We used to do carpooling. Similarly, your resources, same resources, can be shared among different consumer. For example, it's different. The if they want, they can get the dedicated also, right? If that service, because uh, I don't want to have my storage or any machines uh, lying for a longer time without any uses. So whenever I want, I can use it, I can stop it, I can release it. Th- and not only me, even other consumer can also share same resources if it is being offered in a shared fashion, where we can save uh, the cost. When same computing power can be served to multiple requests. Rapid elasticity means services. Suppose I'm consuming service which is uh, serving well my requirement, and in a coming days I need to double uh, the capacity or efficiency or uh, uh, computing power. I can do that. Means it can be elastic as per the request grows, and it can be uh, decreased also in the same fashion if my usage is getting lesser. And measured services means all services should be measured, when for the consumption basis, how much I have consumed that particular services. So these are the five detailed key characteristics which each and every cloud provider should provide. So here we will see in more detail cloud computing essential characteristics, which is on-demand self-service. Means a consumer can unilaterally provision computing capabilities such as server, storage, and network. Means he should not be learning or going through a lot of how to do steps. He should be able to come to our portal, and he can understand that okay, these are the services which are getting offered, and how I can buy it as needed automatically without requiring human interaction with each service provider. It might be uh, uh, it can provision it will provision automatically without human intervention as well. Suppose I have set it. Okay, if demands comes, in place of one machines, increase to two machines. So the it's should trigger the scaling capabilities automatically without human intervention. Broad network access. So capabilities are available over the network and access throughout standard mechanisms that promote use by heterogeneous thin or thick client platforms. For example, those services can be accessed from mobile phones, tablets, laptops, workstations, from any platform. I can go to that cloud portal. I can provision those services. There should not be a way, a specific way to access the cloud resources. Resource pooling. The provider's computing resources are pooled to serve multiple consumers using multi-tenant model. Uh, we will discuss multi-tenancies in more detail later as we move forward. Uh, and multi-tenancy model, right, with different physical and virtual resources dynamically assigned and reassigned according to the customer demands. So as the customer demands comes up, it can scale it can scale up, scale down. That we say scalability, elasticity in the service, and there is a sense of location independence in the customer. Generally, has no control or knowledge over the exact location of the provided resources, but may be able to specify location as a higher level of abstraction, easy country, state, or data center. Means end users should not be having impression that where my service is going to be provisioned. They don't need to worry about. They don't need to understand or think where my service is going to run, in which So machines, which node, which subnet, which is specific network, and all these infrastructure complexity. Those complexities should be abstracted in form of, okay, end user can select which country, which state, and in which data centers I want to run my services. That's it. Example of resource includes storage, processing, memory, network bandwidth, etc. Rapid elasticity, that is one of the biggest uh, characteristics of cloud computing. Capabilities can be elastically provisioned and released, in some case automatically, right? And to scale rapidly outwards and inwards, commensurate with the demand. Means as the demands comes, it will scale up, scale out and scale in. So that should be that our services offered to the consumer. The capabilities available for provisioning often appears to be unlimited and can be provisioned in any quantity at any time. So any services, right? It should not be limit that, okay, this is the limit we have. It should be near to infinite capabilities. If end user wants um, 1 GB storage, he should be able to buy 1 GB. If he want 1 petabyte, he should be able to provision 1 petabyte as per his demands. Measured services. So cloud systems automatically controls and optimize resources use by leveraging metering capability at some level of abstractions appropriate to the type of services, easy storage, processing, bandwidth, and uh, user activities. So each services should be metered, means measured how much it's getting used, and according, and also it should be uh, limit also. Suppose I want to limit for a particular user to consume these services between this range. It should, he or she should not go beyond that. So that kind of metering and monitoring capabilities should be in our services. The resource uses can be monitored, controlled, and reported, providing transparency of both the provider and the customer of the utilized services. So its services should be monitored, controlled, and report. Means that report should show which consumer and which service has been used for how long, and detailed telemetry information of that consumption should be provided into the reporting. So these are the characteristics, 5 characteristics we have discussed. Moving towards cloud optimum uses of resources, right? So why cloud? People used to say, let's use cloud. So why we should go for cloud? First of all, we should be genuine reason for the cloud. So there's a lot of surveys, a lot of industries has did their own assessments, and they realized uh, the the cloud is going to save a lot of money for their IT. So Uh, I would like to explain with this diagrams, right? So, cloud is on-demand, scalable, multi-tenant, self-service compute, networking, and storage resources. So, before this first graph shows how we were maintaining our IT infrastructures in our on-premises, and the second graph shows how cloud computing provisioning happens in the cloud. So the graphs shows demand or resource demands over period of time. So in our on-premises, in our data centers, earlier, if we want to run any applications, we were doing uh, benchmarking and sizing. So in benchmarking, what we were doing, we were assessing the requirement of uh, app- uh, business application from business standpoint. What business wants for this particular application or particular uh, site. So business were demanding, okay, I want this application to be running 24 by 7, uh, 200, 1000 uh, users can access on uh, same time. Means 1 seconds, 1000 user can access this application. And they they were also giving the requirements that at a time user can upload so many data, so and so on. Those were their business requirement. So according to their requirement, we were provisioning our infrastructure, and we were provisioning infrastructure at least keeping 5 years in mind. Means this application is going to run for 5 years, and it might be in starting we are having 1,000 users. It it can increase also. So keeping all those pointers, we were provisioning infrastructure uh, for maximum threshold in the beginning itself. Means, for example, these pointers says that we have provisioned this much infrastructure. Uh, Gradually, uh, the requirement was getting increased, means loads were getting increased, but our services or infrastructure was not able to support. But over the period of time, we started increasing the hardware resources. But what happened after some time? The usabilities goes down, and where our resources were over provision. And again, after some times, request comes up very massively, and that time our for some period of time, our hardware resource were uh, static, and it was not able to scale, and uh, it was under provision. Again, we procured hardwares, and we uh, provision um, hardwares according to the requests. And after some time, again, the requests were getting down drastically, and over period of time, our resources were under provision. And again, uh, uh, sometime again a spike came in. Not I should not use a spike. A spike is the another term, but requests started coming in, and our infrastructure were not able to support uh, those requests. And finally, over a period of time, as uh, application life is about to uh, over, and users were getting mm, uh, started disliking application, and its uses goes down very drastically. And even still we were having our infrastructure provision, and we were paying for those infrastructures, even hardware, software, licensings, uh, cooling systems, securities, uh, space, all those. Uh, we were paying for all those resources. So that was our data center story, and still we have this in our data centers. Uh, but in the cloud, the scenario is different. Uh, Here we provision the resources whatever we are about to consume at present. We don't provision for future. We provision for now. Whatever demand is, for that we provision. We start from minimum most requirement, and we design the scalability parameter for that particular services, so that if that particular threshold comes, it will scale that particular resource or services. So as request goes up, our platform will start scaling itself. As request goes down, it will start scaling our services and infrastructure. So based on the request comes up and goes down, accordingly our infrastructure will be scaled out and scale in. And here the benefit is we are not paying upfront. We are paying whatever we are going to use, and it will keep on supporting the rise in demand. So even in our traditional infrastructure, right, in our data center, it's not possible to meet the business demand because of our procurement process. If we want to buy a cluster of machines, we have to request for that. It will go to the procurement department. Department will uh, do the ordering, and vendor will deliver those machines. It might they will take at least 1 week or 15 days to deliver those machines, and then you have to put into your data centers, keep set up it and make it up and running. So at least it was 1 month process. But here you are able to scale your infrastructure, your services within a minute. You can assume how much flexible you are here, and you are able to serve your business demand. And you are able to save the cost also. So we have to think around these two parameters, cost and business demands, which is the key pointer for any business. And that's what cloud provides. And that's where industries started adopting cloud. It's not because of the fancy word, it's not because of the jargon, it's because of its it's proven factor where they are able to meet the business demand on the fly, and they are saving the cost as well for the business. And that's where who are very dynamic in these scenarios where business demands comes up, their application are able to support. They are the good service provider, and that's where they are able to retain their customer. Suppose in this scenario of travel domain, let's take example. In travel domain, if you are about to book a ticket, I think you don't will stick for half an hour or a minute to browse on any service, browse for a longer time. So you will not be waiting for a longer time, right? For example, make my trip. If it's holding for you longer time, you will jump into another application because there are a lot of competitive app in the market. They will give you the good offers, good uh, look and feel, good usability, and speed also. So that's where people will go instead of sticking with one particular system. In summary, for the cloud adoption, these are the two major factors where business are moving, which is demands, what's according to the time and where we are able to save more cost. Let's move forward. So in this section, we will discuss about cloud computing service model. So even a lot of people get confused about uh, service model and delivery model. So any cloud services can be served in a three service model where we usually say infrastructure as a service, platform as a service, software as a service. I will show this screen. It's very intuitive to understand. For example, in our traditional premises data centers, where we manage everything, means we are responsible for networking, storage, servers, virtualization, OS, middleware, runtime, data, and finally applications. So we have to manage all these layers, and we have to expend a lot of money to keep it running. Where cloud provides their services in three service model, uh, which is infrastructure as a service, platform as a service, and software as a service. So in infrastructure as a service, you will be getting infrastructure uh, in form of service. So what does it mean by infrastructure? In infrastructure, actually, networking, storage, servers, and virtualization is the responsibility of cloud provider. So they will be providing you upfront, and after that you have to worry about which OS you want, which middleware you want, which runtime you want, which uh, data storage mechanism you want, which applications you want to run into that. For example, it's a very good example of infrastructure as a service is VM. So whenever you're going to buy any virtual machines, you will be getting networking storage, servers, and virtualization from the cloud provider, and you have to choose which OS and middleware you want to install into that particular machine. Another service model is platform as a service, where cloud provider will provide you the platform, and just you have to bring in your data and application to run on top of it. Means you will be getting networking, storage, servers, virtualization, OS, and middleware, even runtime. What is the runtime you want? For example, you want to run your application as a .NET application, or it's any Python, PHP. Uh, what kind of application you want to run? Just you have to choose for it, and they will provision for you. And after that, you have to bring your code and data to run that particular application. Another next category is software as a service. Means you will be getting software as a service. You don't need to worry about anything. Just you have to bring your data. Means you have to use it. You have to, for example, uh, email, Google email, or uh, Office 365 from the Microsoft. It is one of the uh, most demanding SaaS in the market. So Office 365 is a suite of Office products where you will be getting all software as a service. You don't need to worry about software. Just you have to uh, run your business through help of those softwares. So these are the three service delivery model uh, from the any cloud provider. So again, these are a detailed discussion about cloud computing service model. We have discussed a lot. Uh, yeah, what is the IaaS? Again, they are explaining about IaaS. For example, uh, in the case, right? In case of IaaS, you want a VM, right? So there is already a VM images available in library. Just you have to choose which VM you want, and you have to choose image. Then it will create VM, configure the VMs, how many processors you want, and provision the database. It will go and it will provision uh, the databases for you. For example, in case of uh, any data is about to store, even for machine also, the machine will be having some storage, internal storage, to store the operating system installer. That's a root drive, right? On top of that, you can install your own applications. You can configure load balancer if you want. Otherwise, cloud provider will provide their own load balancer front end, and then you can manage your VMs. Uh, Again, another persona of the IAS. Uh, there are a lot of niche player in the market who provide IaaS, infrastructure as a service, apart from uh, Amazon, Google, and Microsoft, like OpenStack, SoftLayer, which is IBM offering. Uh, OpenFlow, Google Compute Engine. These are the example of IaaS. So next is platform as a service. So in platform as a service, you will be getting the platform to run your application and data. And from developer point of view in platform as a service, what he has to worry about, he has to just provision database, then it will create tables and data, and finally they will deploy their application. So all dotted line you are seeing here, you don't need to worry about. Only the solid lines like application he has to worry about. And in pass area, there are again a lot of niche players, apart from bigger player. For example, OpenShift, Heroku. Heroku is the one of the good platform. Uh, Cloud Foundry, which is quite in demand for application application deployment. Uh, Pivotal Web Services. Uh, IBM has a lot of Bluemix is the one of the biggest platform. Uh, MariaDB, MongoDB. These are the past offering from these individual niche player. Cloud service model. Next one is the software as a service. In this model, softwares will be getting offered you as a service. For example, WebEx means you don't need to uh, provision anything. That software is up and running. Just you have to start your account and start using it. Salesforce, NetSuite, Microsoft Office 365. These are the example of software as a service. Next, cloud efficiency versus control means in these offering where you will be getting more efficiency and more control. So as you will keep on moving from on-premises to IaaS, PaaS, and SaaS, you will be getting the efficiency of cloud, and where most of the uh, IT services will be taken care by the cloud provider. So you will be getting less control over there. Means you don't need to control the virtualization servers to the networking. The cloud provider will manage that. So yeah, in the standalone servers, for example, in your data centers, you are not efficiently utilizes those services, but you are having full control of from networking to application. But in IaaS, you are having control from operating system to application. In PaaS, just you have to worry about your application. In SaaS, you don't need to control anything. Just you have to come and run your business by using existing applications. So there are a lot of benefits of PaaS for developer. Because developer normally thinks, where we will be uh, using means where we will be getting valued if industry is adopting cloud. So uh, so for the developer, there's no need to focus on provisioning, managing or monitoring the compute storage network and software. Developer can create working prototypes in a matter of minutes. Developer can create a new version of or deploy new code more rapidly. Developer can self assemble services to create integrated applications. Developer can scale applications more elastically by starting more instances. And developer don't have to worry about underlying operating system and middleware, security patches, etc. And developer can migrate backup and recovery strategies, assuming the past takes care of this. So developer don't need to build those capabilities of backup and recovery strategy. Just he has to design it, and underlying platform will uh, control based on their strategy design. But there are a few disadvantages of PaaS for the developers. One, as we see, control, right? So application requires different architecture mindset. Uh, and one of the biggest uh, challenge of adopting cloud for the developer is they have their traditional development mindset, but in the cloud you have to design your application in a cloud mindset way, where we say that you your application should be cloud native, means your application should able to scale in a hundred or thousand instances. It can sync without losing any business data. So they have to think about that and they have to design. And as we know, developer don't have much control over the underlying infrastructure, security, versioning, performance considerations. Means on the platform level, they don't have control. They don't go and debug over there. It's all taken care by cloud. If there is any problem, they have to uh, work with cloud provider, or they have to provision uh, PaaS services in such a way that they can scale according to their application. And next point is cloud computing deployment model. Earlier we have seen service delivery model, how those services, cloud service, can be delivered. So there we saw that IaaS, PaaS, and SaaS are the cloud service delivery model. And here cloud computing deployment model means how anyone can deploy the cloud services. So cloud delivery model uh, is deployment model, how cloud services is delivered to the end users. There are delivery models is public cloud, private cloud, and hybrid cloud, and community cloud. So we can deploy these clouds uh, uh, in a uh, basically three ways, which we say public cloud, private cloud, and hybrid cloud. Nowadays, community cloud are also getting popular. Uh, so the public cloud, what is the public cloud? Means your services is getting offered publicly. That means the cloud infrastructure is provisioned for open use by the general public. It may be owned, managed, and operated by a business, academic, or government organization, or some combination of them. It exists on the premises of cloud provider. Example: Amazon AWS, Microsoft Azure, and Google Cloud. These are the public cloud provider, public clouds. Cloud computing deployment model benefits of public cloud computing. So increase speed and agility, where we can get the our business running in a few clicks, and we don't need to spend lot money on to run our machines in data centers, and we can go to global in a minute. Means we don't need to think about, okay, recently my application is running in the US. I want to run my application in Japan. I can go and provision the services in Japan locations, and we can roll out our application into that region, because the public cloud has its existence across the world. Next one is private cloud. So, private cloud means the cloud offerings you are running in your data centers, and it is for your own enterprise, not for any public person. So, that's the private cloud. So the cloud infrastructure is provision for exclusive use by a single organization comprising multiple consumers is a business units. It may be owned, managed, and operated by the organization, a third party, or some combination of them. And it may exist on or off premises. So it can exist there in their own premises, or they can host their cloud in another premises, means who's having their physical infrastructure, but enterprises can go and just put their racks and start running. So there are few products uh, available in the market which are uh, uh, from Microsoft. We have Windows Azure Pack and Windows Azure Stack, and even OpenStack's private cloud we can build, VMware private cloud we can build. Benefits of private cloud computing. Yeah. So why organization will go for private cloud? The biggest requirement is security. They don't want to run their application into another's infrastructure, or they don't want to move their data out of their boundary, then they will go for the private cloud. So since organization data tightly secured and controlled on servers that no other company has access to, the servers can either sit within the network boundaries of the organization using them, with those servers managed and maintained by internal IT staffs, or they can be located within the data centers of cloud service provider, with an organization accessing data stored on servers via private and secure network links. If the server that form part of private cloud infrastructure are located in company premises, though, an organization does not have to worry about physical security of servers situated in the external data centers of the third party cloud providers. So if they are hosting their servers into another cloud providers, there they don't need to worry about security. But if they are hosting in their own data centers, they have to worry about. They have to safeguard their uh, data centers. Physical security, software security, both we have to take care. Flexibility. So in private cloud, we are owning, and we can get advantage of the cloud offering. So, for example, if we are using massive computation or massive services, uh, and in the public cloud, we will land to paying a huge amount of bills. But here, we can save a lot of money in our private cloud, because we don't need to pay any cloud provider. So where industries like academia and research centers where they uses lot of services and non-profit organizations as well where they don't have money. They can go and build a private cloud with uh, OpenStack or open source applications. So next one is hybrid cloud. Hybrid cloud is the cloud deployment model where you will be using uh, y- private or your own data centers and any cloud. So uh, in hybrid cloud, people used to discuss in a two different way where you can offer your you can run or you can consume the services around two or more public cloud. That term basically known as multi-cloud, which is nowadays getting in demand because bigger enterprises they want to run their services into uh, more than one cloud provider. They don't want to get stuck with one cloud vendor. And hybrid cloud, where most of the enterprises they want to run their applications into their data centers, but they want to burst it into the cloud. For example, if any disaster comes up, my all services will get up and running into the cloud. For the DER perspective, community cloud. So, community cloud, there are a lot of communities like government organizations. They want to run their own cloud, and even other communities like law firm, uh, pharma sectors. They want to have their separate cloud, and their community people will uh, use those clouds. So those clouds are called community cloud. So yeah, so in overall, we have learned introduction of the cloud, and we started from uh, what is cloud, why cloud, and who's were early adopter of the cloud, a bit history about the cloud, and offerings of the cloud, and also delivery and service delivery and deployment model of the cloud. So, in this introduction tutorials, we have discussed in all those areas. I will start creating a couple of more videos around the Azure and AWS, where we will have a feel of uh, Azure services, uh, and I will be explaining most usable services into the Azure, and I will keep you posted, guys. Hope you will like this video, and I will keep on posting my other videos as well.